heat loss is dependent on those three things. Which one is it has to do with insulation?
The DP, right? I know the yield.
Yeah. That's where the insulation comes into play. This is 1 over R, and this is our insulation factor. The larger the resistance, the less heat goes through. Make sense? So we talk also about density and R value. So there's a relationship between density and R value, and that's why we do not pack too much insulation to small space, because you change the density. Why would the changing density plays with the R value? Me.
Becomes so dense that it almost becomes like a conductor.
Okay, yeah. Your conduction takes over convection, and we rely on the air pocket to insulate, because air is a good insulator. If air does not move the turbulence, so it doesn't move.
Insulation is basically a conductor.
Insulation, everything is conductor, and the good insulation is the one that does not conduct as it is, like wool, fiberglass. But also air is very good insulator, so we try to have some kind of porous material that will keep the air trapped in small pockets. That's why sponge foam is good insulator. Fabric is good insulator. And depending on what kind of fabric, some fabric, its material itself does not conduct. So when we push too much insulation and we condense it, we change density, and density does make the convection part and the air pocket disappear. So we do not want to pack way too much. How does it work? It stops heat from moving through. It will move eventually, but it's gonna be slower. You're putting some cavities, you're putting some air pockets, phones off, putting some air pockets that air has to, temperature has to travel through. I would say, which is faster, conduction, radiation, or convection? Well, radiation is pretty fast, because it's a wave.
Conduction.
Nothing faster than light. But if we are conducting through material, which one is faster, conduction or conduction?
Conduction.
Huh? Conduction through material. Convection takes slower, because you have to heat the gas will move until the other part. Anthony, take the phone away. Insulation. So, Eden, would you think material of the same substance will get more value as we increase the thickness, or less? With the R value of 2 boards, will be more than 1?
No, same, but
We put them together, will I have more insulation? Yeah, so it will double, right? So thickness is a function of the material. To a point, we gotta add more and more thickness. So this is 6. What insulation I have now with 2? 12, and so on. So insulation is a function of the thickness and how much material do we have. Thermal bridging, what does that mean? Thermal bridging.
heated bridging.
When we look at that, we see that there are different substances to this wall. So there's cavity and there's also studs. So the heat coming out of the wall will include the heat through those studs. So the studs, what do you think the studs will conduct more heat or less heat than the cavity? More heat. That's why sometimes, again, we say in the winter, if the house is not very well insulated, you can see condensation happening in the wall where the studs are.
Oh,
They are cold, yeah.
Is that why in building 17, in that room where we went the other day with Bill, all the steel beams are covered in insulation?
Yeah, that's why the steel is
That-
is insulated, because of the same factor. And if you have exposed steel, steel is very good conductive, right? It will condensate on the steel, and what will happen? It will rust faster. So it's very essential to insulate steel. When it comes to bridges on water, this is a very side note. You notice that they do not insulate or paint the steel beams in the water. Why? They're not insulated or painted or anything. Why? Especially the sea or rivers. Over time, you'll build up a lot of algae on the bridge. So accumulate some algae and some plants, and those are the best insulators ever. So once it's filled with water and covered with stuff, just leave it. It's not exposed to oxygen anymore. That's why also sunken ships are very, very, very deep. They do not rust. They stay as is for a long, long time. Why is that? No oxygen. So it's a function of oxygen. Meanwhile, if you're on the outside the water, it's humid and there's a lot of oxygen, so it will accelerate the oxidation. So water, we don't want water to come. There's less insulation, and water can come from cavity in the wall, cracks in the wall, submersion in the wall, and another question: how about tracing? So when you have a gutter that collects water from the roof, where does it terminate?
In all of those spots, and then it goes down the spout to the ground.
Yeah. So usually, they don't want to go near the house. Usually you want to be at least 3 feet away from the house. So if you don't have gutter, you have just a roof. The water will seep into your walls and go into your basement. It will go through the cement and go to your basement. So by law, you have to terminate at least 3 feet from the house. So make gutters, make a little bit slanted so the water will go away. Otherwise, you will have always water in your walls, always water in your basement. You increase the humidity. Those sort of things make a difference. Usually the basement made out of what? Concrete walls, usually. Concrete is not completely insulated unless you put some barriers in it. So eventually it will be moist. If you touch it, it's kind of moist. And we say concrete usually never 100% dry. We'll say 100 years and the core of it is still moist. And I don't know if you ever worked constructions or saw people do constructions and building pillars. What do they do after they pour the concrete? Huh?
Don't cover it.
No, they put a cast, right? They put the concrete, it dries out, they touch it, they take the cast out. What do they do then?
Seal.
For sealing. For a few days, they do something called the curing. And what do they do with the curing? Anybody?
And all the water comes out.
Actually, they water it.
Oh yeah, slow the curing process.
Yeah. Naturally, the water actually will speed up the curing process because cement reacts with water. That's why underwater cement works, because actually water unite with the component of the cement and make it harder. So they keep watering, spraying every like few hours, so it will completely oxidize. So that's the beauty of cement. So cement actually does solidify inside the water eventually, even if you pour in water. Once you have to harden, yeah.
Talking about cement or concrete?
Cement itself. Yeah.
What do they mean if you, like I saw this place that had this big cellar already poured in Greenfield, and it was open, and I thought, well, maybe I'll buy that place, you know, it's already got a big humongous cellar, and they said, the building inspector said it's been open to the air too much. I don't understand why you couldn't build on top of that brand new, it's not brand new, I mean, but it looks good.
I don't know.
They said it's been exposed too long.
Yeah, I'm not sure.
I didn't get it, I didn't get the reason.
So, what is thermal mass, Brandon? Can you by the word itself, from the vocabulary, what thermal mass mean? If something has a lot of big thermal mass. Yes. What's an example of material that holds a lot of heat?
Water creek.
Water?
Concrete.
Okay, lava made of stone, golden stone, it's a lot of heat, it takes a while to heat. Actually, now that you think about it, the earth is still cooling off from 4 billion years ago. That's why the earth core is still molten. So at some point the entire earth was a big blob of lava, cooling slowly. It's taking 4 billion years to cool off. That's why the core is molten lava. So a lot of thermal mass. Another idea of thermal mass, we have a lot of limited temperature on Earth, and we keep receiving more from the sun, but we're not emitting back to the atmosphere. So we kind of destroying the balance by adding more heat. But again, there's a lot of thermal mass. Thermal inertia, related to thermal mass. What does that mean?
How fast it can
How
get
fast
heat.
things cool off and how fast they get heated up. Insulation, same material to make insulation, and again, if you find ways to make insulation, you can make a small business out of that. People making business out of paper, tree bark, leaves, hay. There's so many creative ways to make insulation, and how to use old material like foam, boxes to make insulation, and how to make it practical. So, if you were to make insulation now, let's say Matt went out and found out like, he's gonna make insulation out of walnuts.
What?
Walnuts. He found out that there's a lot of walnuts or acorns in the street, he wants to make insulation out of that. And it's wood, it's fibrous, what he has to consider, two things, based on what we said.
You said he wants to get a whole bunch of acorns.
I make the insulation out of them.
And what you need to,
What do you think you have to consider to make insulation out of
It
those?
has to be able to have material to trap air.
Yes, which actually does, because acorn is not a kind of fibrous material. So two things he has to do. Water resistance, and what is the other thing? Fire resistance. So for you, these are the two things you have to consider when you consider insulation. Because acorn is very good insulation. What do they use acorn for? Polishing, right? I know somebody who collects coffee grind. Actually, they make toothpaste out of it and creams and stuff out of coffee grind. Because the material is very soft and does not scratch things. And also they use it for polishing.
So you're saying like you make insulation?
A little bit.
Acorns?
Yes, I think it's,
Oh.
yeah. I don't know if they come. If you find out a way, because there's always people doing new stuff. Fiberglass, they use also old recycled clothing, fibers of rubbers. Huh?
Newspaper too.
Yeah, that's cellulose, it's newspaper. Old newspaper, grind it up, made into pellets, and they make newspaper out of it. So how do you use old material to recycle and make insulation? Okay. Talking about bats and the foil sheet. So we always try to counteract all three modes of radiation, of heat transfer. I would say if you buy a good winter jacket, like a ski jacket has reflective inside, you don't want to be very bulky, so you're gonna have it to be small. And also the outside, you're gonna have some kind of nylon or plastic to stop the air from going back and forth.
What's the idea about foil sheet?
Huh?
What's the idea?
Radiation.
Radiation.
Reflect the rays that are coming out of your body.
It's probably if you like insulate the attic, man.
Yeah. You want to have radiation. You want to have foil. You want to put foil too. Because it will keep the heat inside. It will reflect. Because we said again, everything radiate. I radiate. You saw me with the camera, right? With hot spot, so I'm radiating. And the camera is measuring infrared.
Doesn't matter which side is gonna be like reflecting outside or
Hot to cold usually.
means
the hot part will
should be
reflect outside.
exposed inside.
So
Foil?
if you put the foil from the inside, you will keep the heat inside. If you put the foil from the outside, it will prevent the house from getting hot in the summertime. So that's a good idea. This is also one of the good ideas for solar panels. If you put solar panels, they will cool off your roof because they have a gap between them and they absorb all the heat. We talk about density and weight and why do we need to have density? What is the purpose of this? So when you use boron insulation and you try to stuff loose insulation to a wall, you want to know how much weight to put in there. So you don't want to put less or more. Are we a good example? Okay. Other types, we talk about rigid fibrous insulation. Okay, let's start the recording now. Okay, so this is week 7. We're talking about insulation, and that's chapter 5 in the book. Insulation is very important. It's one way to counteract heat transmission from the house outside, heat transmission from the outside to the inside. So we want to keep the house with its own temperature. As we thought before, we try to have our own microclimate inside the house. What are other types of insulation? There's rigid fibrous insulation that is used to insulate masonry, So if you build with bricks, anybody did any kind of masonry work? Laying stones or bricks? The bricks have cabins. In a lot of hot regions, especially in the south, they insert some kind of foam inside the bricks to insulate. Because this cavity, even though it has air, it still will conduct heat. Steel and wood building components, as Chris said, steel beams are covered with blankets of insulation because they conduct a lot of heat. You want to do that. They are expensive. Rigid fiber stuff are very expensive. These boards are very expensive, relatively speaking, but they're very durable and they're good for foundation and marine application and solar collectors. Can give you an example of rigid fibrous paste, casted. What was the most common thing that we used to use in the 70s? Asbestos, very, very common, very rigid, very durable, but it was actually still, it's okay. If it's still installed, that's not a problem. It's when it becomes airborne, it's when you have a problem. And they have a lot of replacement now for these kind of paints and rigid fibers insulation. Some people actually now make a mixture of kind of mud with hay and other natural material, and just by knowing what you know now, you can mix it. You kind of aggregate with some kind of cement or sticky material with some kind of fibers to make some kind of insulation. Blown fiberglass and mirror wall, those are also very good insulation, but it's not something you want to do on your own unless you have the right equipment. What do we say about fiberglass and fibrous stuff? They can become airborne, and some stuff when they get lodged in your lungs, they really have a job. So be very, very careful with these materials. They're made out of waste bats with lower R value than bats. Why? Because bats are compacted and organized in an array the way it's supposed to be. This is just like loose. So we change the density with these. There's all the bales. You can buy the bales of fiberglass mirror wall. You can buy a bag of them and do whatever you want with them and put the insulation. They're good also to fill in cavities. If it's contained cavity, you don't want to put that in a place where there's a lot of air movement. Because eventually it will get loose. Require blowing machine with an agitator. So there's a machine that has a big fan in it that will pull in those little fiber and little pieces into a small, smaller particle, and they will go and fill in space. Phones off, guys. Let's see you. Pay attention. Issues with the machine. So if you ever had blown in insulation, the machine will get stuck. They need to be loosened sometimes, and those little fibers will go into the rotor itself. So there are some issues with the machine, but there are some procedures to get this done. And sometimes we've actually seen people with shovels goes and put those in cavities. Over fluffing can be an issue. So they try to fluff the material to fill the cavity, but over fluffing can be an issue because of what? What happens if you over fluff it? You change the density, and density has a relationship with the resistance, and also eventually it will settle down, and you don't have the R value that you want. So for the ceiling and attics, they require R value at 316 and 32. The higher R value in the ceiling you have, the better. Because what happens to the heat? It will rise. So the temperature there is 77. Okay, 77. If they put this here, probably it's going to be around 79. So it does get there, inch-wise. So here is going to be really hot, and you want to have the most insulation you can from the ceiling. Fiberglass should be at least 0.7 pounds per feet cube in density. When you go to Lowe's or Home Depot or any place to buy insulation, look at the R value and look at what density and weight. Otherwise, you just bought a bag and you filled it with it, you did not get that insulation. So what are the specifications? And that usually is labeled by law, it's labeled on the insulation. So you don't get less than you want or more than you want. And I have a video that I will show you about how to make installation in the attic. That's something you can do by yourself to insulate the attic. And I actually, MassSafe and Columbia Gas, they have a program where they actually do the installation for you for free. If you sign up for the program, they will come to your house, they'll give you your attic, fill it with the insulation, with the settle, and cover it up. And they realize that it's better to do that because that will reduce the amount of heat we have through the house. The less heat you use, the less they have to produce. Okay? Less. So always expect settling. What does that mean? It's blown in, it's fluffed. Eventually it will go down and settle. And when it settles, density has changed. When density happens, what?
Your R value changes.
Your R value will change. So what do they usually do?
They come back and refill it again?
Yeah,
Yeah.
they come back in 2 weeks, they fluff it. They come back in 2 weeks and they fill it again. So more info about fiberglass. This should not be more than 1 pound per cubic feet for ceiling and attics. If you go to the Department of Energy, the DOT, they'll give you all the standards and how much should you expect. They have a lot of information there. And also they tell you what are the pros and cons for each installation. And it's something actually that will save you a lot of money. You can save up to 50% out of your house heating bill and cooling bill by just insulating your house, especially if you're living in an old structure. Most of the houses in Western Mass are built around like the 1960s, 1970s, and a lot of them were not very well insulated. And if they were insulated, the insulation by the time is worn out, washed out, or reacting, or went away. Yeah.
Is this like code for mass, or is it just general knowledge
It's
for
general,
anywhere?
general
Wow.
rule for fiberglass. Again, that's you don't know what type of fiberglass. You have to go and check. Question. It should not be no greater than 1.5 pounds per feet cube for wall. So for wall is different than an attic. 1 pound per cubic feet, which is that now that give you the density. We can use the previous density calculation for the wall cavity to know how much we put inside the wall, so we will not overfill it. Blown mineral wool is denser than fiberglass. Again, that's common knowledge. It's way more. Yeah.
Is that inside a wall?
Yeah.
Okay, because I know,
No, that's wall to the outside. Don't insulate wall from room to room.
because I just recently did a house where we had like 4 inches of rock wool outside, no, Roxel, and then like 6 inches of rock wool inside. I didn't know, it was probably more than that, but
Yeah.
it's like a lot of insulation on that house.
Usually you want to insulate more to the outside wall. Insulating between rooms is not that useful, unless it's a unit or a different floor. But
Yeah, I mean, like these were all outside walls.
yeah,
And yeah, I knew the outside insulation. I knew it would it was hydrophobic, so it
Okay.
would wick the water away from the walls. I knew the whole point of this house was to be green and energy efficient.
Yeah.
All get out,
so there.
I don't know.
You can also use fiberglass with mineral wool. Mineral was very common in the 80s, but it's not very common now. But there are other options. Yeah, it's no longer a dominant insulation, but it was very common at some point. They found better things that are easier to install and with better R value. So this is how we go on filling cavities for the attic. And I have a video that shows you how to do it and how you calculate how much you put in insulation you put. You wait for it to settle, measure the cavity, and you add some more, then you cover it up. And if you're not using the attic, usually you only leave one place where you can come in on a walkway. You don't want to walk with the insulation unless you put some plywood on it, otherwise you will compress it. And if it's compressed, it's not going to give you the right insulation.
More filters.
blown cellulose is ground up newspaper. It's treated with fire retardant again. It's easy and fast to blow because it's very lightweight. It is inexpensive. It has better resistance than air, fiberglass, because it traps more air between its particles. The R-value between 1 and 2, that's really small, but that's about, I think, for inch. It depends on how dense the particles are. So 1 and 2, that's depends on the thickness of the blown cylinders.
Can you
Yeah.
over insulate an attic, just two things, or you just add, you put in like R12, it settles down, come in to blow it again?
You can go up to 36 so as high as you can. Yeah. But at some point, you just like, it will be not adding any more value.
But where's that rate, where's that, you know, that trade-off?
There's a calculation you can make based on the installation, and also how much will it cost you. If it's possible, you can fill the entire attic with insulation.
And how much,
Yeah, it's gonna cost you a lot of money though. And how much are you saving by that? So there's a rate
return on
for it.
investment.
Yeah. Some problems with blown insulation. It absorbs more water than wall fiberglass. It's very highly absorbent. It will trap a lot of water inside. So, would you think that's a suitable option to have in a house by the water? With a lot of rain? No. That's why you don't see a lot of it in Springfield maybe or Boston. But it depends on where you live. If there's a lot of water, it's not a good idea. Unless you have very well insulated attic from water. Question?
In my house, you know, we recently, insulated our upstairs.
Yeah.
And I don't know, for some reason, I guess the people who insulated our upstairs said that they have to put in, so you know where the fan is in your bathroom for the steam and all that? They have to put in one that just runs 24/7.
To the attic. It's venting to the attic?
Yeah, no, it's vented to like outside,
Okay.
I believe, I don't know.
What is your question?
My question is, like, why is that? Like, why do we, like, what is the purpose of having a fan run for 24?
Probably the house is airtight and they realize they need to refresh the air inside the house. So I'm saying that the minimum is 15 per person. So 24/7 is kind of doesn't make sense. Should be a little switch or at least temperature gauge. But venting the whole time is very good. The point is like, that's very interesting is venting to the attic. I've seen that in a few houses where the bathrooms vent to the attic and that has a window. That's a really not a good idea. Huh? You get the ice downs, and what else do you get? Moisture. With moisture comes what? Bacteria and usual mildew. So that is a really dumb idea to have in a house. You can get a hose or duct and take it to the outside. Just opening a window is not enough. So they vent to the attic and they open a window in the attic. That's not a good idea. If you see that, that's a big no-no. Up to 130% of the weight at humid condition. Okay, so if you add a lot of insulation and it's very humid, you open the window and absorb all the square water, it's gonna increase in weight up to 130%. Now you can more than double the weight. Makes sense. Newspaper is light, that dry is different than newspaper that's wet. It should absorb a lot of heat, a lot of moisture. Not good for coastal climate. If you're close to the coast or water, you don't want that. Water can damage the fire retardant out. So, again, we said we have to, if we want to make insulation out of acorns, you have to wash it with fire retardant and also make it water resistant.
So coastal climate, would that be like you live in Boston, or you actually live on a beach?
In a beach, and plus the high humidity. Plus the, even if you look at a lake, low elevation, you can have a lot of humidity, so you might not want that. So again, those two things you have to counteract. Attic insulation density from 1.2 to 1.6 pounds per cubic foot. Expect 15% of settling. And wall insulation, 3.5 to 4 pounds per cubic foot using cellulose insulation. So different density for different material.
So are like soffit vents, are they really like worth it for houses? Because then like you're saying, depending on the humidity of the house, the humidity.
It's a quick fix. It's a quick fix sometimes.
It's a quick fix.
Yeah, there's a lot of quick, cheap fixes to do. It's maybe something, but if it's your house, I will put something like have more longevity.
So soffit vents are a quick fix?
Huh?
You're saying soffit vents are a quick fix?
Cellulose.
So,
Yeah, cellulose is very quick fix.
no, but it's not like in the overhang of the house, you
Yeah.
have the soffit vents that go from the attic. But you're saying like, well, if there's humidity, you're looking at.
No, you should never vent your attic. Period.
You know, you have like, yeah, I know what he's saying.
The soffit vents are gonna keep the attic cold. So
Yeah.
air flows through the gable vents, right, and then create pressure. from the soffit vents to keep
Yeah.
your attic cold. And then humidity can go from the soffit.
Yeah, but for venting any kind of air from inside the house should not be to our cavity. Should put it completely outside.
Why do you have the gable vents?
What is that?
The gable vents help with ventilation past in the attic.
Oh, that's a different thing. That's for cooling.
Right.
That's the summer. That's that thing you want. Actually, you vent from the attic outside, and you have the air from the house comes out. That's completely acceptable for cooling. But venting or exhaust from the house, from the dryer, from the oven into the attic is not a good idea. But I get what you're saying. So what Joe is saying that when you want to use the chimney effect in the house to cool the house in the summertime, you have a big vent from the attic to pull air through the house. That's used for cooling. And if you think about it this way, the vent is coming from the attic outside and not to the attic. So you're not doing a push pressure. So if we have a house, you can put a vent in here. And you have vents through here. So the air will go to the outside from the attic and be pulled.
No, he's talking about proper vents.
What do you mean?
The vents that go up against the wood in between each bay, before you put the insulation,
Yeah.
there's a little vent that goes.
Yeah, you have vents in here.
From the bottom all the way up and
Yeah.
out.
But it goes along the roof line from bottom to top.
Yeah.
That's what it is.
From here?
Proper vents.
Yeah, oh yeah. So the other way to vent is to vent from here to here, completely with conduit. No?
No, you follow the roof line from the bottom to the peak,
Okay.
like that. They're proper vents. And you put them in before you put the roof on, or the plywood
It's
on.
a piece of foam that goes like this, and then it goes up against the wood to keep the wood,
Does
air
it vent?
flowing.
Okay. Does it vent to the outside?
Yeah, it could come in one soffit, air could come in and go up through each,
Okay.
and then down through the
Yeah,
other
okay.
side.
I know what you're talking about. Yeah.
Yeah.
Or the other
Yeah.
way.
As long as you vent outside, then you're fine. Yeah. Don't vent the solid cavity because that will again cause ice dams and cause humidity increase.
Seems like those things are so compensation.
That's
What is
keep air moving.
again more types of insulation? Vermiculite and perlites. They are used to put with concrete. So they mix them with cement because we said cement is very conductive. So these things have high rigidity and also good insulation. It's kind of like popcorn. Very rigid. They have rigidity, very strong, but they also do not conduct a lot of heat. They're popcorn-like. They have less void than other fillings.
Oof.
Huh?
There's no E.
Pope, like that's like the bathroom.
Popcorn.
Swallow corn.
There we go.
Pickle the autocorrect then. That wasn't me, by the way. And now it's still wrong. Okay, so popcorn like, they heat them, they expand. A lot of chemicals inside, they expand and they make a foam like out of rock. They have less void than other fillings.
Oh, is it like that packing insulation? Like
The peanuts?
Yeah.
It's kind of like it, but it's made out of kind of rocky material.
Okay.
Not ceramic material. Can be mixed with cement and aggregate to make concrete, to make it more insulated. They have R value of 2.4 or less, which is very decent. depending on each thickness. Okay, so this is for inside construction. I have more information about plastic panels, but I think that's enough for today. So.